Not everybody is cool enough to own a gourd banjo, but thankfully yours truly is. Look at this beauty. I just finished building this, and it's possibly the most beautiful instrument ever made out of a fruit. I think it's a fruit. I don't actually know what a gourd is, but that's okay. You know, this doesn't really have much to do with this video, but actually no, that's not true. It has a little bit to do with it because I'm going to show you the latest excuse from Zach on not finding a job, and that is I made a music library. This is not something that's new to me, as some of you might know, because I already made one a couple years ago called Edna, which is a closure music library, and the whole idea was it would be really great if we could represent music as just data, not function calls, not an API, just a bunch of data that is nested arbitrarily. And also it specifically was for MIDI music, because I don't want to deal with lower level stuff like sound waves. I want to just, specify the instrument, specify the notes, and nothing else. I don't want any of that other bullshit. Just MIDI. So that's why I built it. And I really feel like the design stood the test of time. It really, really works. But of course, this year I became, I'm going through my little honeymoon with NIM. I love it. It's a great language. And I've been rewriting a lot of my closure stuff in NIM, or at least making versions of it. And this is one that I did not expect I could do, because, the JVM has a built-in MIDI synthesizer. A lot of you might not know that, but it does. And I'm relying on that for this library, along with another library. So I figured, in NIM, this would be too hard to do, because it doesn't have that stuff. But guess what I found just a couple days ago? This amazing little library called Tiny Sound Font, which is a single file C library that implements a MIDI synthesizer. And I was looking at it and I was like, holy shit, it looks pretty easy to use. It's one single C header file. I can do this. I can build a NIM equivalent to my closure library. And so that's what I did. And it is called Paramidi. And this is only a couple days old, so don't expect a whole lot. But if you scroll down, you'll notice something interesting. Some deja vu. You can see here, compare it to Edna. It looks pretty much the same. Slightly different syntax. This is what closure syntax looks like for data. In NIM, I chose to use tuples because they are very flexible. And then I just defined some enums to define the instruments and the notes. So everything works basically the same way. You specify an instrument and then any arbitrary notes can follow it. And then you can also have these little tuples that specify attributes that change the behavior of anything coming after it. So like if you write octave 3, then all the notes coming after it will have that octave. And of course you can change it as well after that. So you can change the length, you can change all that stuff. And it works the exact same way as Edna, pretty much. And and here's a cool little thing. If you want to represent a chord, you just create a set and then put the notes of that chord inside of it. And Paramidi is smart enough to just play that as one chord. So, you know, it looks very eerily similar to the Clojure version. It's weird because these languages are so different, but sometimes they just coalesce at the same point. Like this syntax is not all that different than this. And you can play things, not just notes at the same time, you can play entire measures of different instruments at the same time. So in this case, you got a banjo and a guitar playing at the same time using this little thingy called concurrent mode. So none of that is really going to make sense unless I actually play some music here. So let's go to, what do I want to do first? I'm going to go to the Paramidi repo and go into examples. This has a couple of examples, the same examples that are in Edna, just to show that, you know, these are basically equivalent libraries. So the first one is called, fittingly enough, Dueling Banjos. And if you're not a, you know, if you're not a banjo connoisseur like this guy, Dueling Banjos is basically the, you know, one of the more popular banjo songs, at least in pop culture, because of the movie Deliverance, which probably did more to hurt the banjo's image than anything else. But anyway, let me look at this. So this actually is a good example of one really neat thing about representing music as data. Well, a lot of music has repetition in it, right? You know, the chorus or whatever. Well, if you're representing it as code and you're able to represent each piece as data, well, you can just put it into a separate constant, like you see here. I have all these separate measures, and then I just create one big score that has all of the banjo and guitar pieces, and most of them are just using one of the measures. So you reduce a lot of the repetition when you represent it as code. And you may have noticed it's a little weird that this song is called Dueling Banjos when it's not two banjos, but doesn't matter. All right, so let me actually play it because you've heard me talk enough. So I'm going to go into here and do Nimble Run Dueling Banjos. So let's listen to this. Listen to this little masterpiece here. The other thing, you can change the tempo as well at any point in the piece. So it started getting faster at the end because I changed the tempo to 120. All right, so that's Dueling Banjos. All right, so maybe some of you less cultured people are not into that. That's fine. Some of you might recognize this next one. And, well, I'm going to give it away because I'm going to type it out here. If you're into Final Fantasy, all of that was written in NIM, and it's written as data, as you can see. So it's a very closure-y way of solving this problem, but I think it's a very effective one, because this library, the public API, is two functions, believe it or not. They are compile and render. So compile, this little guy right here, takes that score, this huge thing, and turns it into a sequence of MIDI events that I can actually then turn into music. So I give that to render, which then turns it into actual, bytes of waveform data that you can then save to a file, like a WAV file, or play directly. And that's it, just two functions. And the reason I can get away with that is the entire API, so to speak, is just data. It's just give me the notes, if they're chords, put them in a set. Just a few basic rules that you can combine arbitrarily, infinitely, to produce any kind of piece. So that's what that looks like. That's a big example, and if you want to get started, the easiest way is this much smaller project I made called Paramidi Starter. Okay, so I link to it right here, and this is a really nice way to get started. So Paramidi Starter. So this just gives you the bare essentials. It starts you off. Actually, I think it has the very first measure of Aries theme inside of it. Okay, so this is like an easy way to get started, and just to make sure it works here. Yeah, so it's actually the same song, but not the whole thing. And so you can start making music right away, and start modifying things. For example, I'll change this to an organ. Okay, whoops. Now I'll play that again. You can check the source code for all of the instruments. There's a huge number of instruments here in an enum. Where is it? Right here, the instrument enum. So you can find whatever you want inside of there, and actually use it. So now there are plenty of things I still need to do, because I've only been working on this a couple of days. Like, one thing I really want is live code reloading. That's a huge part of Clojure. It's harder to get in NIM, but I have some ideas. NIM has this new compiler API that lets you run the NIM script compiler to basically run a subset of NIM at runtime. And I'm thinking of using that to create this loop where I can edit my score, send it to the NIM script compiler, and then rerun this part down here. And I think it will work. And that will allow me to avoid the recompile loop. Although the compilation is definitely faster than in Clojure, so it's not that bad, but I still would like more of a hot code reloading experience. So I'm going to work on that whenever I get the chance. And I don't know, I've got other things I want to do to improve it. You can output to a file, to a WAV file, and from there you can just put it anywhere. Another thing that's kind of cool, if you in the starter project, if you build a release build, so D-release, it actually creates a self-contained binary that contains the entire sound font. If you're not familiar with sound fonts, they're pretty big, because they have to contain a lot of data. This one is 30 megs, I think, and basically I wired this up so when you compile it with release mode, it's actually going to put the entire sound font inside of your binary so that you can run this file on any computer with no dependencies, and it will be able to play that song without anything else installed, not even NIM, right? It's just a random Windows executable now. So I'll just, you can just run that on any computer. No sound fonts need to be installed anywhere because it's inside of the binary. The downside, of course, is that the binary is bigger. Like, let's see how big it is. Yeah, it's like 30 megs. Now, most of you probably, if you're making music, you just want to output it to a WAV file, and the project already does that by default. It's called output.wav, so you can just play this in VLC. So you got a lot of options for how to use it, and yeah, I mean, we'll see where it goes. I got a lot of ideas, but this was really the main thing I wanted. I just wanted to reach something close to feature parity with Edna, which took me a lot longer to build than this did. So I was really happy that I was able to just get it to this point where I could actually make the same music. In fact, I actually copied and pasted the Edna examples, like, Aries theme. This is what it looks like in Edna. So it's not all that different, but I just copied it and changed the syntax into NIM, and boom, it was playing the exact same song. So obviously for me, this is mostly about game development. I want to make music for games. That's what most of my para whatever projects are. But you can use it for any purpose, So yeah. That's all I got for you, folks. I hope I blew your minds. I hope you liked it. If not, screw you.